Hello, my name is Philip Paul with World Construction Solutions, and we're working on a patent right now, building machines that lay curved sewers. This drawing right here is to show you that normal sewers are laid straight because they're laid with this laser beam. They're laid with laser beam because the accuracy, because you need to fall for up to miles. You can only lay about 400 foot at a time with laser beam because the curvature of the earth, the weather conditions inside the pipe. You have a lot of times blow air and things because all the condensation and the temperatures difference, which makes the laser beam move and bounce and curve. It's kind of a weird thing to see. You have the very powerful laser, battery packs and everything to last all day while you're shooting through the long distance. Installers set up a laser. This is representing the laser right here. Red or green beam or whatever color you want coming out of it. You type in your slope for your fall in your pipe, maybe 0.03% slope. You shoot that out. Maybe this is a manhole here, just the end of a big pipe. You shoot the beam through the pipe. As you go through, your installer sets a target, such as this, with a plexiglass colored screen, bullseye, and this is your laser beam representing coming through that. It sits inside the bell, and that way you can move it up and down whatever way it's got to go to get the pipe online centered to lay the pipe. Problem with the old system is that it's a great system. The problem is, though, it has one major drawback. You can only lay sewers straight, only lay them up to about 400 feet at a time. A lot of sewers companies don't even like it 400 feet apart, and you've got to use manholes at each point to turn. Since the development of GPS using the lasers, I've come up with a different way to do this, and they'll seem all the same basically. This model right here is 2 GPS antennas. Zoom in here a little bit more. In line with each other. On a pole. So this is 4 foot from here to the laser beam. Laser mounted. These 2 antennas are, let me zoom in here a little bit, are on a hand stick, in this case, this first prototype, with this receiver and this receiver being perfectly straight with each other, perfectly same altitude. On this bar, if we go down, say 4 foot, and mount a laser at the same straight as the antennas, should be able to move the antennas into position, calculate 4 foot below them, and that'll be the laser beam. So they can follow a line per se in space. That line now can be curved because we're not aiming through the pipe, we're aiming back at the pipe, at the target. So the installer uses the same target, still sets it in the ground, still puts the bell in there, moves it around. He can still take his shovel or a grade stick and break the beam with it to see what grade is. Nice thing though is the operator that's digging for this pipe can now see the laser beam on his inside of his bucket or in the dirt as he's digging, or as dust comes up, he can see and get an idea where grade is himself. In the old days, or in now times I should say, soon to be the old days I believe, laser beam going through the pipe, operator could never see the end of the beam because it would be on the backside of his bucket. Backside, so that was all, no help from his eyes to help me, just all what the laborer and installer told him. This is a very simple way to do it. This is all hand adjusted for prototype number 1 for outside of any kind of pipes, ditches, anything you want. But as the GPS tells the end of this laser where on this curve that's drawn on a set of blueprints that's been installed, each time you move this device, it'll make you come to that point, and then it'll make you aim back to the last section, so the beam will go back. So this is a straight line here. The pipe is bent at the joints. I don't know whether you can see this here. Let me zoom in, but see how the pipe, you can bend pipe up to, I think, about 10%. This depends on what kind of pipe and how big it is. Or you can use sewer pipe bends or bend the sewer pipe. They have benders and all kinds of things for plastic pipe, or you can use fittings or manholes in that case if you want to, or clean outs, whatever you want to use. So that being prototype number one, that gives us a way to do it, the most cheapest way we can do it. Not always the best thing down in the ground real deep. This would have to be very tall. So we go to the box where we're laying sewer mains. And let me get down here where I can zoom in on this thing. Find a small point here. And here we go, zoom. Of course, it takes forever when you're on video. Zoom selection, okay. Now, so what we did in this case is we have a trench box which keeps the men safe in the ground for installers. We mount the dual antenna GPS receivers, computers and their own batteries, on the box. This is already predetermined inside the computer of how big the box is and what it takes to get to this point of the poly line, or the line that is inputted into the system that the laser is going to follow. If you can imagine being down on the ground, this would be out of the way, that way of the machine digging, reaching down here. This is the pull bar that the machine pulls the box through the ground, the shield, they call it, to protect the men, or installers, I should say. But this right here unit would be basically inside the wall of the unit so that it's safe while it's being dug and drugged. Once it's drugged, then the installer and or the operator will both have some kind of a key fob, or I should say a remote control device, maybe on their belt loop, on their wristwatch, in their iPhone, I don't know. But when they hit that button, because they're getting ready to go down there, then all of a sudden this thing could come out. It could basically slide, out of the wall, out of the protective area. It can go up and down, whatever it's got to do to find that point of the laser beam. And you can see here is a line up and down, and we get right that on. That should shoot the last pipe in the ground for verification if you had your target in there. Well, now the installer can, it's got the laser beam just like before, puts the pipe in and lines it up with the laser beam, lays pipe, gravel, gets all done, says, hey, I'm all done now, and pushes his key fob, the laser thing goes up, over, and inside of a protective area. So the reason for all that, and that those two linear motors moving that laser beam, twisting and aiming light, is it knows in space where it's following that line. It's aiming back. It changes. Only thing it changes is a setup time for using the old laser shooting down through there. It's basically installation is quicker, and it could be S-curved back forth. The grades could raise up and down in areas if needed to. Maybe you come up to a hill and you want a certain amount of cover, and now you can draw on the blueprints to start making the rise a whole lot sooner. That's the beauty of it, and it's going to make sewer laying much more efficient, buying, like I said, less manholes, which is just a huge cost. You can jet out for over 1,000 feet, so you can put a clean out every couple thousand feet. Huge time savers, so bring the cost of the job down that way. Huge cost of material savings. No manholes made out of concrete anymore that the acids are eating up and getting rid of. So, and not buying massive amounts of easements. The easements costs are just crazy because you got to try to lay straight lines along a curved road or around things. It's just not hardly possible. So, with the new technology, thank God we can start thinking different ways to do this stuff. Well, thank you very much. My name is Philip Paul. World Construction Solutions is the company, and curvesewer.com is a place to look at this as we develop it and it grows.